Okay, so we're doing bounded area. Okay, so we're going to find the area bounded by these functions. We have a cubic function and we have a linear function. Now, I always tell my students to sketch these just so you can see what's going on. So that's what I'm going to do. So this is 0, 1, 2, 1, 2, -1, -2. So, real quick, this is the cubic function that's been shifted to the right one. So there's that point there, 1, 1, -1, -1. So this side looks like this, like that. Okay, so there's my cubic function. And on the other side, y2 is just a linear function with a slope of 1. So here's its y-intercept at -1 with a slope of 1. And there you go. So, if you don't know how to graph these and you had to do it by hand, you'd end up having to FOIL out this y1 and set them equal to each other and all that good stuff. Now, there is a formula that will help you out with that if you know about Pascal's triangle. There's a really easy equation that says this: a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. So you can use that to FOIL out this y1. Okay? Now, since we have our points of intersection, we know that we have two pieces of area we're going to be finding. We're going to be finding this area here and this area here. Okay? So, to find that area, we're going to set up two integrals. We're going to use vertical strips, so we're going to be using this equation. The integral from a to b, the function on top minus the function on bottom, dx. But we're going to have to create two of them in order to find this area. So, let's start with our first area. Our first area goes from 0 to 1. Our function on top is the cubic, so it's going to be x minus 1 cubed minus x minus 1 dx plus the second area, which starts at 1 and goes to 2. But on that part, the top function is the linear function, and the bottom one is the cubic. So these are our integrals, okay, to find the area. But before we get started and do all this, there is something that we can use to make our life easier, like the fact that the cubic function is symmetric around its origin. So this point right here is its origin, so this side here and this side here are symmetrical, which means these two areas are also identical. So instead of doing these two integrals, we can actually just find one of them and multiply it by 2. So we can find one of the areas and just double it because we have two areas of the same exact area. You can only do this if you know for a fact that they are symmetrical. Okay? In this case, they are. So I'm going to use this one to double it. And the reason I'm going to do that is because not only will I have only one integral to do, one of my limits is 0, which means I'll only have to plug in one of my two limits to find the area. So doing it this way, it's going to be 2 times the area from 0 to 1 of x minus 1 cubed minus x minus 1 dx. So that's what this lesson is about, is sometimes you can actually simplify these areas with symmetry. Okay? Now, we're going to use this equation right here, because now we do have to FOIL it out to find our integral. So this is going to be 2 times integral from 0 to 1. And when you FOIL this out, you're going to get x cubed plus, minus 3x squared plus 3x minus 1. And all I did was use this equation right here. Basically, erase this. I'm FOILing out x minus 1, which means a is x and b is negative 1. So this is going to be x cubed plus 3 times x squared times negative 1 plus 3 times x times 1, because negative 1 squared is positive 1, plus negative 1, because negative 1 cubed is going to be negative 1. So that's all I did, is I used that equation to help me FOIL it out. And then I'm going to distribute in my negative, so I get this dx, so negative x plus 1. Now add up my like terms, make my life easier. So then I'll go from 0 to 1. This is going to be x cubed minus 3x squared plus 2x dx. And now it becomes a really, really simple definite integral problem. Take the antiderivative, so this is going to be 2 times x to the 4th over 4 minus x cubed plus x squared from 0 to 1, which means this is 2 times 1/4 minus 1 plus 1, which is basically 1/4 times 2, which is 1/2. And for my students that need the code for today, it is BR0K3N. So really what this is about here is sometimes when we do these areas, we can actually split it up into equal parts, or we can put it together knowing that both of them are the same areas and just do one of the pieces and multiply it by 2. So it's not any different than what we did in geometry when we would do composite areas and using symmetry of, say, rectangles or triangles to help us out.